So in this video, I want to talk about one of the example of SAT math problem. And the question is, if g of x is equal to ax squared plus 24, and function g is defined above, a is a constant and g of 4 is equal to 8. What is the value of g of -4? And there are some choices of our answer. And before we solve for this question, let's think about our solutions for this question. And at first, we need to know the definition of the basic functions in order to solve for this question. And in a second step, we also need to remember the calculation based on the equations right over here. First, let's think about it in terms of a function. So, a function. So for the function in this question, the function is the unknown variable in front of a parenthesis, or sometimes you just write it's just a unknown variable. So the unknown variable in this case is g. So you can see that there is a function g. And we can see that the function should always take its factor, which is x, in this case right over here. Sometimes function doesn't take its factor, it just write as factor, it just write function g is equal to ax squared plus 24. And there's a function that g of x, but it contains a specific equation. And it is ax squared plus 24 according to a question. So at first we put a input value. So we put an input value to its factor of g, function g, which is a factor x. And also there will be a function. We'll make a function at first, and then it will convert and it will be a output. And we need to remember that if we inputted x value into for our factors, we also have to input the value to our equation that contains same variables. So at first, we can just express it through our equation, and we know that g of x, and that is equal to ax squared plus 24. And the thing that we can know from our question is that g of 4 is 8. So we can see that g of 4 is 8. So we can see that if you input a value of x into 4, that will going to give us 8. And they are asking us the value of g of -4. And here all we have to do at first is find the value of a, which is a coefficient of the x term. So we can say that the value of a will going to be at first, we know that g of x is equal to ax squared plus 24, and if we inputted the 4 into x value, it gives us 8, which means we can write in this way: g of 4 is equal to ax squared plus 24, and that should be equal to 8. But we know that we inputted our value of 4 to the value of the x squared, so we can convert x squared into a 4 squared. And we can simplify our expression that a times 4 squared is 8 times 16, and then plus 24, and that is equal to 8. And all we have to do right now is subtract 24 to the both sides to isolate 8 times 16 to the left side. And then we can get 24 and minus 24, we're going to cancel out, and we get 8 times 16 is equal to negative 8 minus 16 minus 24 is negative 16. And we can divide the whole expression down into 16 to isolate a term in the left side. And then if we divide it, we get a is equal to 16, and a 16 we're going to cancel out as 1. And we get a is equal to negative 16, and the 16 will cancel out as negative 1 and the 1, which means the value of a is negative 1. And we can use this theorem you can use this answer for a into our whole expression. And we know that our function is g of x, and that is equal to 8x squared plus 24. All you have to do is input the value of a, which is negative 1, so we can input our value. Instead of a, we can input negative x squared plus 24. And now we can just input our values, and they're asking us to find the value of g of negative 4. So we can see that g of negative 4, all we did is we input the x value into negative 4. And so that is equal to negative, instead of x squared, we also have to input the negative 4 to this value to make this equation satisfy. So negative 4 squared, so negative 4 squared, then plus 24, and this is a third step. So we can get the answer negative, and then negative 4 times negative 4, which is negative 4 squared, will going to be negative 16 plus 24, which will going to give us negative 8. So in conclusion, we can say that g of negative 4, and that is equal to negative 8. So our answer for this question will going to be A in this case. And all you have to remember is that at first we talked about the function that there is a function, and it contains the variables or factors sometimes, and then it has a specific equation. And with that equation, if we input values, it will going to make a function, and it will going to come out as a output. And in the second step, all we did is we found the value of a missing variables in order to make this equation easier to solve for this question. And in the third step, we found the value of g of negative 4, which is negative 8 in this case. And our answer for this question is A. So at first, let's think about graph of a function. Actually, it is not important the graph of the function when it comes to solving for this answer of this question, but the reason why I'm doing this is because when you go to more advanced SAT function math problem, it's hard to solve it if you don't really know about a graph of the function. Let's talk about in terms of a function graph. We can write our functions right now that g of x is equal to negative x squared plus 24. So g of x is equal to negative x squared plus 24. And we know that it is a second degree quadratic term, which means if you convert it into a graph, it will going to be a parabola. So if you graph it, it will be something like this. And it will keep going down. Here we can know one thing, that the graph form is going downward, which means it is going down. So I'm going to talk about the two cases where the case 1 is when the parabola goes upward, and the second case where the parabola goes to downward. So let's say the coefficient of the x squared term is a. So we can see that coefficient of the x squared term is equal to a. The case where the parabola goes upward is a case where the a is greater than 0, which means the coefficient of the coefficient of the x squared term can't be negative or positive if it wants to go upward. So if I draw upward to compare with a downward right here, it will be something look like this. So if I graph it, it will be something look like this that is opposite with a downward form. So for the downward form, it is a case where the a, which is a coefficient of the x squared term, is less than 0, which means it should be negative all the time. So right now it is negative x squared plus 24, which means it is going a downward. And let's talk about this point right over here. There's a special point right over here where the graph of the downward form goes increase and then hits a maximum point and it goes all the way down. And it is a point where the x is equal to 0 with the coordinate because it is on the y-axis, which means if we make it into coordinate, it will going to be 0, comma, the unvariable number y. But we can find the value of the y since we knew that if we input a 0 to the x term, it will going to give us a output. So at first, let's think about g of x is equal to negative. If we input 0 to the x term, it will going to be g of 0. That is equal to negative 0 squared since we input a 0 to the x terms, and plus 24. We know that negative 0 squared will turn into positive, and we can see that the g function g, if we make it onto the coordinate, it will going to be y value. So we can see that our value of y is equal to 24. So we can input that value to our original coordinate. So 0, 24. And we can know one more thing about the vertices right over here and then right over here. It is the cases where the x is a positive and the y is 0. This is a case where the x is negative and the y is 0. Y is 0. This is on x-axis. So if we convert into a coordinate this case vert, and it is on the negative, so we can say that it is a negative x value, comma, the y value is 0 since we need that it is on a x-axis. So it is negative x comma 0, and same thing here as the x value with a noise, so we can see it's on the positive, so we can write x comma 0. And now we can talk about the forms of the parabola. Definition of the parabola is that it is all setup point that satisfy this equation right over here. So at first we can think about the forms of a equation right over here. G of x is equal to negative x squared. So g of x is equal to negative x squared plus 24. And for g of x is equal to negative x squared plus 24, it is in the standard form. The standard form is a form such as ax squared plus bx plus c. And we can see that our value ax squared in this case is negative x squared. And the value of c, which is a constant, will going to be 24. And in this case, the value of the bx right over here, it will going to be 0. And it doesn't really affect the graph of the function. And the only thing it affects is that when we make it into a binomial, this quadratic. And I'm going to talk about one more thing about the upwards and the downwards. When the a is greater than 0, so let's say g of x is equal to x squared plus 24. And this is a positive, which means when it goes to upwards, since we need that a term is greater than 0, which means the positive, the coefficient, the constant term, will going to be a minimum point right over here. And all we have to care about is a sign or negative or positive of the x squared term and the constant c. And let's talk about in terms of its c when it goes downward, which means the a, which is the coefficient of the x squared term, is less than 0, which means it is a negative, such as g of x is equal to negative x squared plus 24. And we know that it is negative, which means it will hit a maximum point right over here. So we can know that the coefficient of the x squared term, which is a, it is positive. The c, constant c, will going to be a minimum point. And when the x squared term's coefficient is negative, the c will going to be a maximum point of the graph.